This is Algebra 1, Homework 8-5, Dividing Polynomials. In the first two, we have a relatively easy procedure where I simply take this 9x and I divide each of these terms by 9x. So let me go ahead and rewrite that so you can see what it looks like. I'm going to have, zooming in even more, I'm going to have an x cubed divided by 9x. I'm going to have a plus 4x squared divided by 9x, and I'm going to have plus x divided by 9x. I typically do this in two stages. The first stage, I'm simply looking at the coefficients and making sure those are all the way reduced. Luckily, in this first problem, 1 and 9 are reduced, 4 and 9 is reduced, and 1 and 9 is reduced, so I don't have to do anything unique with the coefficients. So the only thing that's left for me to do is I need to look at the variables and do the properties of exponents. Remember that each of these x's is an x to the power of 1. And that one is also an x to the power of 1. I'm going to be subtracting the exponents because I'm dividing their bases. I'm going to say, when I have division here, I'm going to do 3 minus 1, and because 3 is the larger number, it's going to stay in the top. I'm going to say I have an x to the power of 3 minus 1 here, and 3 minus 1 is 2. I'm just going to go ahead and write the 2. And then I am going to leave the 9 in the denominator and call it reduced. From there, I'm going to do the same thing. I have the 4 and the 9, which are already reduced, and I'm going to use properties of exponents, again, to say the larger numbers in the top, which means the x is going to be in the top, and I'm going to do 2 minus 1 to give me a 1, which I'm not going to write the 1, I'm just going to say x. And then finally, I'm going to add, and there's two ways of thinking about this one. You can say 1 minus 1 is 0, and anything to the power of 0 is 1, or what I prefer to do is just cross them off and just say they're gone, and I just have 1/9 remaining. So 1/9, and that's my final answer, which I will then box. Let's go ahead and check our work. X squared over 9 plus 4x over 9 plus 1 over 9. I got it correct. On to number 2. It's going to be basically the same thing, and instead of rewriting everything, I'm just going to divide each individual term by 6n to the power of 3, divided by 6n to the power of 3, divided by 6n to the power of 3. In almost all of these, the coefficients don't need to be reduced. 1 and 6 are reduced, 1 and 6 are reduced, but 6 and 6 can be reduced. In fact, instead of dividing the top and bottom by something, I can just cross, and now it's reduced. And then I use properties of exponents once again, and I can say I have a 6 minus a 3, which is a 3, so I'm going to have n to the power of 3 over 6, plus, and then 5 minus 3 is 2, so I'm going to have an n to the power of 2 over 6, plus, and then there's no coefficients to worry about, and it's n to the power of 4 divided by n to the power of 3, so 4 minus 3 is 1, so n to the power of 1 is just n, and I get my final answer, which I will then box. Let's go ahead and see if that's the right answer. N cubed over 6 plus n squared over 6 plus n. I got it correct. We are on to number 3. In number 3, this is the first kind of tricky problem. The general idea here is I'm thinking of this entire polynomial as the area, and I'm thinking of this entire binomial as the height, and I'm saying if I do area divided by height, I should be able to get this equal to the base, because base times height will give us area if we were going forward. So this is kind of going backwards. So setting up the problem, the general idea is I'm going to have some sort of box set up where this box could go forever in this direction and forever in this direction. But I know in general, I already know my height. My height is going to be just too long. So I'm going to go ahead and make that now. This is going to be too long. So there's my two subsections. You can see there's 1, 2 subsections, and I don't know how many are going to go over here, so maybe it's going to be 3, 4, I don't even know. In Algebra 2, they go pretty long. In Algebra 1, the most we're ever going to do is a 1, 2, 3 units long. So from here, I'm going to start filling in the height. The height is x plus 4, so I'm going to say, yes, this height over here is x plus 4. And then I'm trying to find the base. The base, sometimes people think it as the bottom, but the base is technically that length as well. These two lengths are the same length. So if I find this length, I'm done. The way that I do that is I start by filling in the area and using logic to fill in the rest. So I'm going to go ahead and cut this into pieces. So cut, and we'll add as many pieces as we need. That's a good amount for right now. The first area that I have is a 4x squared. Usually the biggest degree term is going to go into the top left cell right here. So this is going to be a 4x squared. And then I start asking myself, what side length times the side length of x gives us an area of 4x squared? Well, 4x times x gives us 4x squared. So I can say that this length has to be 4x. And because this length is 4x, I can now find the area of this cell down here by multiplying 4x times 4 to give us a 16x. And the cool thing about the area models is that these diagonals, at least for our class, is always going to have they're always going to have like terms. If this is an x right here, this also has to be an x right here. That's what it meant going forwards when you have descending and ascending orders of degree. So this has to be an x. In fact, these are the only x's that we have. This can't be an x right down here. Only these diagonals, if I had a really big problem, I could have like a bunch of diagonals. These two numbers have to add up to 19x. So what number plus 16 adds up to 19? And the answer is 3. This has to be a 3x. And now we know that I can find this length. I can say this length times this length is this area. What times x is 3x? 3 times x is 3x, and technically that's a positive 3. I'm putting in a plus here because eventually my answer is going to be written here, and I don't want to say the answer is 4x 3. I want to say 4x plus 3. So now I can say what's 3 times 4 to get our area down here, and that's going to be 12. Now this is a problem because hopefully we are trying to get a 12 here, and we would have no remainder, but we definitely need a remainder. How do I get from 12 to 20? I need another 8. So I'm going to say I need another plus 8, and that's usually our remainder. And the way that we write remainders, we say that that remainder is divided by whatever we are dividing by x plus 4. So that's going to be my final answer. I'm going to not rewrite that and just simply box and say that was the answer, 4x plus 3 plus 8, and I get 4x plus 3 plus 8 over that x plus 4. I got the right answer. Let's try the same thing with 4, but we'll go a little bit faster. I won't explain so much. So again, I'm going to have this box down here. I know, whoa, I wanted it to not be a trapezoid. I would prefer it to be a rectangle. Let's see, there's our rectangle. And I know that because I have the same number of terms, 3 by 2, and this one was also 3 by 2, I know I'm just going to have a 2 by 2 area down here. So let me go ahead and get that set up. I know that the area is going to be 2 by 2, so I'm just going to divide in half. I know that preemptively. It's annoying me that that line isn't perfectly lined up. There we go, a little bit better. Although it's not here. There we go. There we go. All right, so I'm being really nitpicky right now, aren't I? That looks nice. I know that my height is going to be an n minus 8, and I know that my area is going to have to start with an n squared. So what side length times this side length is n squared? Well, n times n squared is n squared. And then from there, I can say this n times this negative 8 is going to give me a negative 8n. And I know that because this n is on this diagonal, this also has to be an n up here. And then I say, what n plus a negative 8n is a negative 12n? Well, I need to go another negative 4. So I'm going to say negative 4n. And now that I know this area, I can now say, what length times n is negative 4n? And I say, negative 4 times n is negative 4n. And now that I know that side length, I can say side length times side length is area, and a negative times a negative is a positive. 8 times 4 is a 32. And this is a cool example. In this case, I don't have any remainder. I try to get 32, and I got 32. So the remainder is 0. So there's a pedantic way of saying, well, technically this is a remainder of 0 over n minus 8. And 0 divided by anything other than 0, of course, is 0. So I can just cross out this whole thing and say, well, that's just 0. And I don't want to say n minus 4 plus 0. So I'm just going to, scratch that whole thing off and be like, okay, that's the actual answer. It's n minus 4. I'm going to go ahead and box the top because that's where our answer lives. It's n minus 4 for our final answer. Let's check number 4's answer on the back. It's just n minus 4. In fact, that's you can kind of look at all the future answers. All the future answers will have remainders. That was the only one that doesn't have a remainder. That might happen on the quiz or the test where you have no remainder. Just be ready for it. And then number 5 is a little bit tricky. Notice the difference between number 5 and number 3. In number 3, the powers went 2, 1, 0. And number 4, I went 2, 1, 0. Now look at the powers of number 5. It goes 2, blank, 0. We're missing 1. We're missing a power of 1. Where's our just normal k? So you don't have to do this, but it's one of those things that definitely helps students that are new to this. I'm going to rewrite our problem and say this is really 4k squared plus 0k plus 6. And then it's still divided by 4k plus 4. Having this placeholder of 0 will remind us when I'm trying to get my k terms, make sure that the coefficient is a 0 so that there isn't a k term in my area. Okay, I know that this is still going to be a trinomial divided by a binomial, just like the previous problems, a trinomial divided by a binomial. So it's going to be a 2 by 2 area for our rectangle. So I'm going to go ahead and set up our 2 by 2 area. I think that is enough space to do that. And I'm going to divide this into two pieces, divide it in half, divide it in half. Looks good to me. All right, so I know one of the heights is 4k. Oh, I was about to write a plus right there, but plus comes down here, plus 4. And I know after knowing the height, I know that the area starts with a 4k squared. So the question now, again, this 4k squared just came down here. Now the question is, what side length times 4k gives us 4k squared? And the answer is just k. So I'm going to now multiply k times 4 and get 4k. And then here's probably the trickiest bit of this entire problem. The reason that we have a placeholder here, I know that after I have my value of k to match the diagonal, what value goes here so that I get my 0k? 4k plus what k equals 0k? 4k plus a negative 4k. The opposite of this coefficient will add up to 0k. These both get canceled out, meaning there's no middle term here. But to get this area of negative 4k, what does this side length have to be? What times 4k gives us negative 4k? Just a negative 1. And now that I know that side length, negative 1 times 4 gives us a negative 4. Okay, we weren't trying to get a negative 4. We were trying to get a positive 6. So I need to go up 4 to get back to 0, and then up another 6 to get to 6. 4 plus 6 is 10. I need to go up another 10, so I'm going to add 10 to that, which is our remainder. So I'm going to divide that by 4k plus 4. So one of the things that you need to start doing is looking at that remainder and asking, could I reduce you? Because that's probably not going to be the answer on the back. I'm noticing that both the numerator and denominator here can both be divided by 2. 10 can be divided by 2, 4k can be divided by 2, 4 can be divided by 2. Watch what happens when I do that. I can say divide the top by 2, divide the bottom by 2, and that's going to be 5 over 2k plus 2. So I'd like you to start doing this. I don't think I'm going to take off points for now because I'm not really assessing how well you can reduce polynomial fractions. I'm assessing if you can use long division. So if you just wrote that as your final answer on the quiz or the test, I will give you full points. But I really, really would prefer you to know how to simplify. Let me go ahead and check. I believe that the answer is going to be, let me go ahead and write the whole thing again. I think the answer is probably going to be k minus 1 plus 5 over 2k plus 2. I'm going to go ahead and box that after all of the reduction. Let's go ahead and check. K minus 1 plus 5, k minus 1 plus 5 over 2k plus 2. Yep, so it's exactly that. So if you accidentally, well, I guess not accident. If you only got that and you're confused, now you know why. You're reducing that remainder. Same thing is going to happen in number 6, like number 5, where I have a placeholder value in here. I'm going to say that this is a 2x squared plus 0x minus 41 to remind ourselves of what's going on. Again, I'm still doing a trinomial by a binomial, so I know my answer is going to be a a 2 by 2 rectangle. Not quite a rectangle. Let's try you again. 2 by 2 rectangle, please. Good enough. Go ahead and cut you in half. Cut you in half. Good enough for me. I know that the height over here is going to be a 2x plus 10, and I know that the area, we're going to start with our 2x squared and bring it down in here. We're going to have a 2x squared. Again, the question is, what side length times 2x gives us 2x squared? And the answer is x times 2x gives us 2x squared. And then I'm going to multiply side length by side length to get our area. X times 10 is just 10x. We know that the diagonals will always match. This has to be an x. And because we're looking for a 0x, or aka no x, we have to do 10 and a negative 10. I should do that in ink. Negative 10 will cancel each other out, meaning that we have 0x. Now that we know that this area is negative 10x, we have to ask ourselves, what is this length? What times 2x gives us a negative 10x? And the answer is a negative 5. And then from there, I can say negative 5 times 10 is a negative 50. Our goal was to get a negative 41, but we got a negative 50, sorry. How do I get from negative 50 to negative 41? I add 9. I'm going to add 9 all over 2x plus 10. And from here on out, I'm always going to finish off by asking, could we reduce this remainder, that fraction of a remainder? And the answer is no. I can only divide the top by 3. I can only divide the bottom by 2. So I can't really do anything, and that's going to be my final answer, which I will then box. That's not a very good box, is it? I think I'm going to just go ahead and freehand a box. Let's go ahead and check. X minus 5 with the remainder of 9. X minus 5 with the remainder of 9. All right. Number 7 gets a little bit bigger. Notice instead of doing a trinomial divided by a binomial, we're doing a polynomial with 4 terms divided by a polynomial with 2 terms. So it's a little bit bigger, which probably means instead of doing a 2 by 2 down here, it's going to be a 2 by 3 down here. It's going to have 1, 2, 3 of these spots. So let me go ahead and get that set up. I'm going to have 2 there and I think 3 there. I think that's going to be enough room like that. So I'm going to go ahead and divide you up 1, and then another line will make 3 different segments, 3 different terms. I know it's not perfectly a rectangle. Turn it into a trapezoid over there on the right, but that's okay. All right, we know that the height is going to be 2n minus 10, and we know that our area is going to start off with a 2n cubed. So the question again, what length times 2n gives us 2n cubed? And we're going even faster, we get an n squared. Then we say 2n squared times negative 10 gives us a negative 10n squared. We know that these diagonals will always have like terms, so this n squared is going to pop up here and give us an n squared. The question is, what n squared plus a negative 10n squared add to a negative 26n squared? And the answer here is a negative 16. From there, the side length must be negative 8n rather, because negative 8 times 2 gives us the negative 16, and n to the power of 1 times n to the power of 1 adds up to n, or I guess multiply to n to the power of 2, but you do add those exponents. Now that we have the side length of negative 8n, we multiply by another negative 10. Negative times negative is a positive. 8 times 10 is an 80, and then don't forget our n. Because we have an n here, we're going to have an n up here. And now that we know that it's an n, we have to add these two diagonals. 80 plus what gives us a 74? And the answer here is a negative 6. Now that we know that area, what times 2n gives us a negative 6n? And the answer here is a negative 3. And then I say negative 3 times negative 10 gives us a positive 30. And we were trying to get a 33, so that means to get from 30 to 33, we need to add an extra 3. Add an extra 3, which is our remainder, and the remainder is over 2n minus 10. Don't forget to check. Can we reduce this? We cannot. We can divide the top by 3, and we can only divide the bottom by 2. That is very similar to number 6, isn't it? But yeah, that's our final answer, which I will then box. I'm going to probably have to freehand box this one. There is our final answer. Let's go ahead and check. N squared minus 8n minus 3 with a remainder of 3. We do indeed get that. Number 8. Again, it's going to be the same type of thing where you have a 4-term polynomial divided by a 2-term polynomial, meaning that our area here is going to be a 2 by 3 rectangle. So I'll go ahead and get you set up, please. There we go. And then cut you into 3 different pieces going this direction, cutting into 2 pieces going this direction. I think that's going to be enough room. Do I need to move one of these lines over? I can move this line over a little bit. That kind of gives us more equal spacing. I know that the height here is going to be a 3b plus 6, and then I'm going to start on my area. I know that my area starts with a 9b cubed, and I ask myself, what times 3b gives me a 9b cubed? And the answer here is a 3b squared, and then I'm going to multiply. 3b squared times 6 is going to be an 18b squared. Because I have a b squared here, this also has to be a b squared by the diagonal like term theorem. I don't even know if it's a theorem, but the pattern that we noticed. And then from here, I'm asking what b squared plus 18b squared adds up to a 12b squared, and the answer here is a negative 6. Now they add up to a 12. And that means what side length times 3b gives us a negative 6b squared? I need a b, and I need a negative 2, so a negative 2b. Now I can multiply. Negative 2b times a 6 is a negative 12b. And then again, because this is a b, this also has to be a b. And I ask myself, what b minus 12b gives me a 3b? Well, I need to go up 12 to get to 0, and then up another 3. 12 plus 3 is 15, so I'm going to say 15b. What times 3 is a 15? And the answer here is a 5, a positive 5. And 5 times 3b, yep, that does work out. And then 5 times 6 is going to be a 30. We were trying to get to 31, but we only got to 30. So to get from 30 to 31, we need to add 1, and then that's the remainder, so it's going to be over 3b plus 6. And I'm trying to make my 6's look different than my b's because they can be confusing. Can I reduce this final remainder? The answer is no, which means that must be my final answer, which I'm going to box in red. Let's check. 3b squared minus 2b plus 5 with a remainder of 1. 3b squared minus 2b plus 5 with a remainder of 1. Excellent. On to our second to last problem, number 9. Here we go. Again, it's going to be 4 terms divided by 2 terms, which means we're going to have this 3 by 2 rectangle ready to go. So let's go ahead and divide you up, cut you up once and then twice. And then we cut you in half twice. Okay, we know that the height is 2n minus 4. So let me fill in. We have a 2n minus 4. Let's start filling in our area. We have a 16n cubed. And I ask myself, what times 2n is 16n cubed? And I have 8n squared. And then I say 8n squared times negative 4 is a negative 32n squared. If this is an n squared, this must also be an n squared. And then I ask myself, to get my n squared, to get this negative 28, how do I do negative 32 plus what gives me a negative 28? I know that it's going to be a plus because these are opposite signs. Therefore, this number will go down to like a 28 or something. And then the distance between 28 and 32 is 4, so it must be a plus 4n squared. What times 2n is a 4n squared? Well, another 2n. And then that's a positive 2n. 2n times 2n is 4n squared. And I can now multiply 2n times, oh, no, I want to do 2n times negative 4 is a negative 8n. Again, diagonals should have like terms, so this has to be an n up here. And then let's go ahead and figure out how do we get our negative 24. What plus negative 8 right here? Yeah, so what plus negative 8 equals negative 24? And the answer is a negative 16 plus a negative 8 is a negative 24. And now that I know that this area is a negative 16, what times 2n gives me a negative 16n? And the answer is negative 8. So I'm now going to say negative 8 times negative 4. Well, the negative times the negative is a positive. 8 times 4 is a 32. All right, we were trying to get to a 24, but we got a 32. We went overboard. We need to subtract some stuff. How do I subtract to get from 32 to 24? We subtract an 8. So I'm going to minus an 8, and then I'm going to divide that by whatever we were dividing by, 2n minus 4. And then the last question I always ask, do we need to reduce our remainder? And the answer in this case, finally, is yes. Yes, we can. Check this out. We can divide the top by 2, and we can divide the bottom by 2, which means every single of these terms is divided by 2. And that means our final answer is actually 8n squared plus 2n minus 8 minus 4 over n minus 2 for our final answer, which I will then box. And the box can look nice this time, please. More or less. 8n squared plus 2n minus 8 minus 4 over n minus 2. We got it correct. So that was, it looks like numbers 5 and 9 were the problems so far that needed to be reduced for that remainder. Last problem, number 10. It's going to again be 4 terms divided by 2 terms, so we know that our area is probably going to be the same as they have been for the last 4 problems. Let me go ahead and set you up. Good enough. Divide you into 3 segments on the horizontal and 2 segments along the vertical. Excellent. We know that the height is going to be, I want to change my color here, my height is going to be 3p plus 8, and I know that my area starts off with a 3p cubed. So the question is, what times 3p is 3p cubed? I just need some more p's. I need 2 more p's to be exact, so p squared. Now that I know it's p squared times 8 is an 8p squared. Again, we have our diagonal rule. P squared means that this term up here has to be a p squared, and I need to get a 17p squared. What plus 8 is 17? The answer is 9 plus 8 is 17. What side length times 3p is 9p squared? Another 3p. And that's going to be a positive, so I'll write a plus here, plus 3p. So positive 3p times a positive 8 is a positive 24p. And because of our diagonal rule, if this is a p, this must also be a p. And I can ask myself, I'm trying to get 45. 24 plus what number gives us 45? And the answer here is 21. Okay, now that we know the area 21, what number times 3p gives us a 21p? And the answer is a positive 7. And I can multiply. 7 times 8 is going to be a positive 56. And we are trying to get 53. How do I get from 56 to 53? We have to subtract 3. So subtract 3, and that's the remainder. So we divide that by 3p plus 8. Can I reduce that remainder? And the answer is no, because 3 and 8 are co-prime. So that has to be our final answer, which I will then box. Let's go ahead and check our work on the back. P squared plus 3p plus 7 with the remainder of minus 3. We got it correct. That concludes the homework 8-5 for Algebra 1.